Hello, my name is Sunil Agarwal. I'm a Principal Program Manager with SQL Server team. And today I'm going to talk to you about In Memory Columnstore technology that I'm really excited about with SQL Server. If you look at today's environment, the data sources that are generating the data is growing exponentially. By devices and data sources, I mean you look at the cell phones, you look at smart meters. So as an organization, you need to manage this data. The data is growing through these devices exponentially. And your goal is to manage this data in a very efficient way and be able to do analytics on this data for your business advantage. So we believe there's an opportunity here to process large amount of data in a very efficient way. And SQL Server column store technology is designed to address that. Let me first start off with a demo that shows you what you can do with column store technology. So in this demo, I'm going to start with a row store table and look at the query performance. And then I'm going to enable column store on that table and look at the query performance after enabling column compression. So let me start with this database, AdventureWorks database. This is available in our download center, and I encourage you to download and try it. And I'm going to start with enabling the statistics time on to see what exactly the query performance is. And this is a query. This is a very typical query that you will run for your analytics. And notice it is running on a fact table, which is currently stored as a row store table. And let me run this query. And this query is running. It has to fetch the data from the storage process, and it came back. And if you look at the time it took approximately 150 milliseconds to compile. And then notice it took 5.7 seconds to execute. And this is a pretty good response time. Now let's do one thing. Let's enable column store compression on this table, all right? And what I need to do, which I just have to run this command here, create cluster column store index on this table, and that's all you need to do. And let's assume that we have done that, and the table has now column store compression on it. And for this demo, what we have done is we are calling the same fact table that we had before, and I just changed the name of it, and it's calling CCI as the postfix. So essentially the same table, but it is now column store compressed. Now remember, there was a 5.7 execution time for the table that was stored as row store. I'm going to run the same query, and you can see it returned much faster. And if I look at the query performance, it ran in 0.44 seconds compared to 5.7 seconds. Right there, you can see not doing anything to the query, I got 20 times better query performance, right? That's a key benefit. So that is the query performance. Now let us look at the storage savings, what column store can give you. If I just look at the space used, both on the table that was column store index and without column store index, let me look at the space used. So what you see here is that this is the first row, shows that the table with the column store index. You look at the size, it's approximately 699 megabytes. This is the total size of the table. And the same table with row store is taking 2.5. So in this example, what you're seeing is that I'm able to get 5 times better compression on my table. Again, by doing nothing, all I did was I created a column store index. So that's the power of column store index, where you can get amazing amount of compression and improved query performance without changing anything to your application. Just create column store index, and there you go. So in the demo, you saw that you could compress the table in a very significant way, saving a lot of storage while still delivering a great query performance. So the question is, what is the magic behind how SQL Server achieves that? And the magic sauce is the column store technology. What column store technology is, the data, when you store as column store, is stored in columns rather than as a row. So what you see here is a table which has 5 columns, and each column, like in this example, column C1 is stored independently of column C2 and so on. So the advantage is when you store column C1 independently, all the values in the column C1 are stored together, and since they come from the same data type, you can get a very good compression. So because of that, you can get a huge amount of compression in your table. And as I talked about, you can get on average 10 times compression. It depends on the data. Sometimes you get even more, sometimes less, but typically you get around 10 times compression. Now, this is very useful for your analytics because analytics, when you do on a large amount of data. And if you compress the data well, you reduce the I/O in a very significant way. So if I compress the data 10 times, that means I'm reducing my I/O by 10 times. So that is one big advantage of column store technology. Now, the second advantage is since the data is stored as columns, we only need to bring the columns that are referenced in the query. Unlike row store, where all the columns are stored in a row, and if you were going to do a query on, say, column C1 and C2, you still need to bring columns C3, C4, and C5 because those are stored as part of the row. So by just bringing the columns you need, for example, C1 and C2, you're already reducing the I/O 60% because it is bringing those two columns. So only the columns that you need are fetched into the memory. The third thing that we have done is with the column store is we process the data in a very efficient way. We process the data in a special mode called batch mode, which processes a set of rows together. Now, this is actually very useful in a data warehouse or analytics scenario because the amount of data that you're processing is large. So if you process a set of rows together, you can get efficiencies in terms of execution, and that gives you amazing query performance on top of the data compression that you got. And we in SQL Server team believe very strongly that column store technology is the right tool for you for your data warehouse workload to manage large amount of data while still delivering great query performance. There are two things I want to point out in this slide is when you store the data as columns, we don't store all the values in a column in one unit. What we do is we break the data into chunks of million rows, and those chunks are called a row group. So basically imagine this, if you have a table with say 100 million rows, we will break the table into chunks of 100. Each chunk will contain million rows. So you can see here that the first row is first chunk, okay? And then we store and compress the columns in each chunk separately. The benefit of this approach is that we can run your query using the subset of data. We just have to bring that chunk into the physical memory to run the query. So that chunk is called a row group, and each column within that chunk is stored independently, and that is called a segment. So essentially, when you think of a column store index, you have row groups, and within each row group, you have a segment which represents a column. And these two concepts are very useful to understand what happens in terms of query performance later on. Now, let's show a simple example. If you're, say, running a query. Here, I'm running a query which says select product key, and you want to find out what was the sales on that product. And you want to run that query where the date is before a certain date. So in this case, the columns that I want to access are product key, the sales amount, and the order date key. Those are the three columns I want to access. And notice this table has 6 columns. So when you run this query in column store, first thing SQL Server understands that you are only looking for 3 columns. So the 3 columns in between are not fetched. So right there, you're reducing the I/O by 50%, assuming all the data is stored with equal length, which is not the reality, but for simplicity, let's assume it is. So you're reducing I/O by 60% here. The second thing is we look at the predicate, which is saying order key with the date is below certain thing. For each of those chunks that I talked about, the row groups, we know what the minimum and the maximum value for each chunk is for each column. So we know using this metadata that we do not need to fetch the second chunk in the bottom, right? That means to run the query, I just need those 3 columns in chunk 1. So by this, you reduce the I/O even further. So the query processing, you get a lot of benefit because we are eliminating the row groups and eliminating the columns that are needed to process the query. So that is one aspect of column store technology. Now let's look at the second aspect, which is the batch mode processing. Now, what is batch mode processing? Batch mode processing is that you want to access and execute the data in a set of rows. What it means is that if I have to process millions of rows, I do not want to process one row at a time. I want to process a subset of rows. So in SQL Server batch processing, we process up to 900 rows together. So in this example, what I'm showing you is that you do a scan of a table and you are fetching three columns, C1, C10, and C14. And when you scan the rows, we are not getting one row at a time. We get, in this case, say 900 rows. And now if I want to apply the predicate, when I'm applying the predicate, we figure out of those rows that I fetched, which rows satisfy the predicate. So we are sending this set of rows up the execution tree. Now, because we are processing set of rows, we get efficiency in execution, and that gives us a tremendous performance gain for the query processing. With the batch mode processing, what we have seen on average, it can give you 4 times better query performance than if you ran the query without batch processing. So batch processing, along with extreme data compression, gives you the query performance that you need for an analytics workload. So the column store technology was introduced in SQL Server 2012. We improved it in a very significant way in 2014 by introducing updatable cluster column store index. And this has been very successful with our customers, and many customers are using cluster column store index to manage their data warehouse. And we in the SQL Server team continue to invest into this technology. And in SQL 16, we have made even more improvements in terms of performance and functionality. And I'm really excited here to share those enhancements with you. In SQL Server 2016, we have enhanced column store index in 2 key categories. First one is performance. For performance, what we have done is we have added new batch mode operators. As you know, a batch mode operator can give you a speed up of query performance by an order of magnitude. So the new operators that we added are sort, which is a common operator that you have in your analytics. Sure, you have used order by. So that sort is done in batch mode. That means you get better performance. The second operator category is the window aggregates. This is again very common set of operators that you have in data warehouse. And those operators now in SQL Server 16 execute in the batch mode and more. So with SQL 16, when you migrate from 14, you can run your existing queries without any changes and get these performance benefits. So you just upgrade and you get huge benefits. The second category that we have done in performance is the aggregate push down. So aggregate is like sum, max, min. So these operators in SQL 14, they were fetching the data from the scan of the table and then apply these aggregates. What we have done in 16 is we push the aggregate to the scan operator. So what you get out of the scan is the pre-aggregated data. And by doing this, we have seen 4 to 6 times better query performance. And again, without requiring any changes to your queries. You move from 14 to 16 and you have aggregate operators, you get the performance benefit. And the third important thing that we have done is the efficient processing of these string predicates. Many data warehouses use string columns, which is varchar or char columns. The processing of those strings has been improved by pushing the string predicate again to the scan node. And by doing that, we can improve the query performance by an order of magnitude. And again, you can get this improvement without changing the application. So the important thing to note is, as you upgrade from SQL 14 to SQL 16, your existing workload will automatically, without requiring any changes from you, will run faster because of these new changes that we have done in SQL Server. Now let's look at the second category of changes, which is in terms of the functionality. If you look at SQL Server 2014 cluster column store index, you get amazing amount of compression because we are storing data as column, and that's the only index allowed on the table. Now, the benefit of single indexes that is simplifies the management of your database management very, very significantly, because you don't have to worry about which index to create to speed up what query. In many cases, the single cluster column store index can deliver query performance for a wide range of queries. However, there are workloads in our customer that we found where they wanted to enforce primary key, foreign key constraint, which they could not do in a very simple way. You could work around using a materialized view, but that was one challenge. The second challenge was if my query was going to fetch a subset of rows, there was no efficient way to get those queries. So those were some of the challenges that we saw with the cluster column store index in 2014. And we handled those challenges by adding new functionality to the column store. So now let us look at what we have done for 2016 in terms of functionality. So same column store index just like before, but what you could do now is you could create one or more non-cluster indexes on top of cluster column store index. So think of this as a non-cluster index that you would create on a traditional row store table. Now you can create the same kind of indexes on top of a cluster column store index. Now, by doing this, you get multiple benefits. The first thing is you still get the right amount of compression that you have seen before. Of course, now you add index, so there's an overhead because of that. But these indexes, the non-cluster indexes, provide you two key capabilities. You can enforce primary key, foreign key constraint in a very efficient way by creating those constraints on these non-cluster indexes, as well as you can speed up the short-range queries or equality queries using these indexes, because these indexes, when you traverse, you can point to the row directly instead of doing the full table scan. So with the non-cluster index functionality, we believe we can address the short-range queries extremely well and give you the capability to enforce the primary key and foreign key constraints. Now let us see these things in action, both from a performance perspective and from the enforcement of primary key and foreign key using a demo. So in this demo, I want to showcase the functionality and the performance changes that we have done in 2016. And I'm going to compare the performance gains over SQL 14 side by side. So you can see when you upgrade to 2016, what gains you can get without making any changes to your application. Since I'm going to run both SQL 16 and SQL 14 on this box, I'm going to limit the physical memory available to each instance. So I'm giving us each instance 3 gigabytes. And for now, I'm going to set the compat mode of my database to 130. And first thing that I want to do is showcase the non-cluster index that you can create on a cluster column store index table. Okay, so I'm going to drop this table. And I'm going to create a simple table called my fact table. And thing to notice in this table is that you have a primary key on product key column, and it is enforced using a non-cluster index. So I'm creating a non-cluster index on product key column as a primary key, all right? Now, let me, after the table has been created, let me create a cluster column store index on this table. Now, this command would have failed in 2014 because you could not have a non-cluster index in 2014 if you have a cluster column store index. So let me run this command. And you can see now I have both the cluster index, cluster column store index, as well as non-cluster index on this table. And to showcase, let me go back to my database, which is this database. And I'm going to refresh this table. And if you look at the index, you see I have a cluster column store index as well as a non-clustered index. Now let us see how I can enforce a primary key using this index. So here I'm inserting a row, and the row will succeed because this is the first row I'm inserting into this table. Now if I insert the same row again, of course it will violate the primary key, right? So I run it again, and there you see the primary key violation was caught. So this is one simple example how you can enforce a primary key on your table with cluster column store index. The second thing I want to show you is that SQL Server, when processing queries, will choose the non-cluster index automatically. To showcase that, let me switch to my database to AdventureWorks, which I had shown before. I go to the database, and in this database, I have a table called CCI test. The table that you see here, it has a cluster column store index and a non-cluster index. Now, what I'm going to do in this table is I'm going to run a query which says select star from this table where finance key is equal to 10. Now, I have a non-cluster index on finance key. So query optimizer should choose this index because this is the most efficient way to run this query. So I'm going to enable the query plan here, and I'm going to run this query. When I run this query, you will see that SQL Server Optimizer automatically chose the non-cluster index to run this query as you would expect. So key thing is with the non-cluster index, you can enforce primary key and you can get very efficient execution of equality search as well as range searches. Now let me switch gear and I'm going to show you the aggregate push down to show how query performance is improved over SQL 14, all right? So what we have here is a table. I'm going to switch to the TPCH database here. And what I'm going to show you is a very simple aggregate. So I'm running a query on a line item table. Okay, let's look at the line item table in TPCH database. This is the line item table here. And notice that I have a cluster column store index on it. All right. So if I run this query, it's going to run in batch mode. And the query is run. And if you look at the query performance, I need to search, enable the IO on so that we can see exact query performance. So let me go here and set statistics time and IO on. And let me run the query again. And you will see that this query ran in 0.11 second, right? The total execution time is 0.11 second. And if I look at the query plan, this table actually had million rows, 11 million rows, but aggregate was pushed down. So what happened, all aggregated computations actually happened at the scan node. Now let me contrast that query when I run the same thing on SQL Server 14. So let me run the same query on SQL Server 14 and execute this one. And this is connected to SQL Server 14 here. Just like before, I'm going to set the configuration appropriately so that we are comparing apples to apples. And I'm going to turn the stats IO on and time on. And I'm going to use the same database. This is basically I have two copies of the database. One is running with 16 and one is running with 14. And the compat level is 120. And now I'm going to run the aggregate pushdown, the one that we saw before, right? And I'm going to enable the query plan. So when I run this query, it took a little longer. And notice when I did the aggregate, this is the aggregate operator. In SQL 14, the aggregate is done outside of the scan. The aggregate is not pushed down. So that is one visible difference that you see. And if I look at the query execution time, and notice it is taking 0.47 seconds compared to 0.14 seconds that it took before. So by, again, making no changes to the query, you just upgrade to 16, your query is running much faster because we push the aggregates down to the scan node. So what I showed you in this presentation, the column store technology, you can get amazing amount of data compression and a very good query performance for analytics that can help you manage large amount of data that you see in today's environment. And we in SQL Server team continue to invest in this technology. And in SQL 16, we have added significant amount of performance improvements and functionality to make managing column store index easier and more performant. So I really encourage you to try SQL 16 and see what column store can do for your workload.